Welcome to the video about heating textiles. A heating textile is a textile system able to provide heat on demand. There are two groups of heating textiles. The first one is composed of textile systems without a power supply. For those, the heat is produced by exothermic chemical reaction. The second group is composed of textile systems with power supply. Here, the heat is produced by electrical stimuli named Joule effect. Applications of heating textiles are for thermal comfort, for wellness, sport and transport, for instance. In addition, we could find applications in medical, mainly for pain reduction. Finally, there are some applications in the industrial field for the storage in a constant temperature of a chemical product, for instance, or to manufacture on demand large and flexible ovens for composite parts. The heating systems without power supply are based on exothermic chemical reaction. Oxygen from the air reacts with an iron-based reagent. These patches, supported by textile or to be included in textiles, for example, are usable wands. They are designed to reach a temperature of 40 degrees for 8 hours. The textile parts or textile integration of this product is very poor. Heating systems with a power supply are based on ohmic heating named Joule effect. It is a process by which the passage of an electric current through the conductor produces heat. Two strategies, sometimes very close, are possible to get heating textiles: implementation or integration of textiles by conductive materials. Materials are most often conductive yarns, but could be conductive past or ink, for instance. For these heating systems, a power supply is required. Battery adds weight on the total system and leads integration issue. Of course, the heating lifetime is limited by battery power capacity. If we take heating glove as an example, often products have 3 levels of power, and for the low power, the heating time goes up to 5 hours. But for the high power, the heating time will be only 1 hour. This part is about heating elements obtained by the implementation of textile by conductive materials, and also non-textile heating elements to implement a textile product to get finally heating function. The first example is embroidery to maintain resistive carbon fiber on textile substrate. In this case, product is 100% textile. The second example is printed heating track based on nanotube ink on plastic film. The element has to be inserted in a textile structure, for instance. Another example is this patch based on carbon nonwoven with copper electrodes. The last example is a plastic patch with heating track based on silver ink. Again, these patches must be inserted in textile structure. Here are some examples of heating elements obtained by integration of the heating function. The aim is to have perfect integration of heating parts, often wire, in textile structure. For this, heating materials must be introduced during the textile process. We could cite, as example, heating wire weaving in a narrow fabric, but also the knitting or weaving of copper yarns. The last example is a fully fashioned heating garment made by silver coating polyamide fibers.